We'll now look at some problems where we are asked to determine the area under the normal curve. First, we want to keep in mind that in order to work these problems, we need access to a table that is located in your textbook. So be sure that you open your textbook to section 12.5 and find the table before we get started. I'm going to begin by showing you how to use the table. To work the problems, we will be looking up z-scores in the table. For example, we may be asked to look up a z-score of negative 2.53 for a particular problem. So what we need to do is we need to break this z-score up, looking at the first two digits separately from the last digit. So what we're going to do is we're going to find the negative 2.5 down the first column of numbers, and we're going to mark that row. And then across the top, we're going to find the 100th place digit, which is a 3. And so we're going to mark that column. And then we will intersect the marked row and the marked column to find our answer. And so a z-score of negative 2.53 is going to correspond to an area, which is what we're going to be asked to find, of 0.0057. Now it's worth noting that this table gives the areas to the left of the z-score that you look up. So if you have a normal curve and you have marked off negative 2.53, which is going to be, your zero line is going to sit right in the middle. So negative 2.53 is going to be somewhere to the left since it's a negative number. This axis on the bottom works kind of like a number line. You'll have positive numbers on the right and negative numbers on the left. So negative 2.53 is going to fall somewhere to the left because it's negative. And we will shade to the left of that z-score. And so this table gives us the area of that shaded region. It gives you the area to the left of the number that you look up. If you notice, we also have a version of the table where the z-scores are positive. So let's look at that. It works very much the same way. Suppose that we have a problem where we have a z-score that we are asked to find. And let's just say that the z-score is 1.74. And so again, what we're going to do is we're going to use the first two digits, and we're going to look that up down the left-hand column. So we'll look for 1.7 down the left-hand column. We're going to use the 4 as the 100th place digit, and we're going to find that across the top. And so we're going to intersect our row and our column to come up with our area. And so we will be looking at 9591, right, which remember is the area to the left of the z-score that you looked up. So in other words, if you have a normal curve, remember that 0 is the mean and it sits in the middle always. Positive z-scores will fall to the right, negative z-scores will fall back to the left. So 1.74 is going to sit here. And remember that the table gives us the area to the left of that number. And so we're talking about the area of everything to the left of 1.74 being 95 91. Okay, so now we've seen how to use the table. Let's look at what the problems are actually going to look like. So the first problem says determine the area under the normal curve to the left of z is equal to negative 2.00. So I'm going to begin by drawing a normal curve. I'm going to draw a line straight down the middle for the 0. And then I'm going to mark off negative 2.00. Again, positive z-scores will fall to the right, negative z-scores will fall to the left. So we're going to mark off somewhere to the left, and it doesn't really matter where, negative 2.00. And we want the area to the left of that number. So we're talking about the area of this portion of the curve. So remember that our table allows us to look up the area to the left of a z-score. So we're going to go back to the table that has the negative z-scores. And we're going to look this up. So remember that our z-score was negative 2.00. And so we need to find the area that goes with that. So again, first two digits we'll use down the left-hand side. There's the negative 2.0. The last digit is the hundredths place, which will be across the top. And because it's 0, we're going to be in this first column. So we'll intersect that row and that column, and that gives us an area of 0.0228. And so we're going to go back to our example. 0.0228 will be our area. And that will be our answer for the first part of this example. Okay, let's move on to part B. This says determine the area under the normal curve to the left of 1.19. So notice that we have a positive z-score in this case. So again, I'm going to draw my curve. We'll put the 0 in the middle, remembering positive z-scores to the right, negative z-scores to the left. So I'm going to draw a line for 1.19, and we want to shade to the left. So we're talking about shading everything to the left of 1.19. And so again, remember that our table finds the area to the left of a given z-score. Since our z-score is positive, we're going to go to the positive table. And we're going to look up 1.19. And again, 1.1 will be down the left-hand side. We'll mark that. The hundredths place digit is 0.09. And we're looking at where those two intersect, and so we can see that that is 0.8830. And that will be our area. 0.8830 is going to be the area of the shaded region. The next part of our example asks us to find the area under the normal distribution curve to the right of 1.19. So again, we're going to draw our curve. Put the 0 in the middle. Remember, positive z-scores to the right, negative z-scores to the left. So our z-score is positive. We'll mark it off on the right-hand side. Now note in this case that we want to shade to the right of 1.19. We're trying to find the area of this piece of the curve. Now, if I go to my table and I look up 1.19, which is actually what I did in the last example, remember that looking up 1.19 gives us 8830. So I'm going to make myself a note that a z of 1.19 is 8830 in the table. But now what we want to remember is that the table gives us the area to the left of the z-score. So that 8830 is the area of these two pieces. And it's not the area of the shaded region. So we want to think about how can we find the area of the shaded region. Remember, in our properties, we said that the total area under the curve is always equal to 1. So if we take the total, which is 1, and we take off this 8830, which is the unshaded part, the part that we don't want, if we subtract those two, that should give me the area of the shaded part. And so this is equal to 1170, or 0.1170. And that will be our answer. Again, the total area under the curve is equal to 1. So these two numbers have to add up to be 1. We know a part of it that we don't want, so we're going to subtract that off. And that should leave us with the answer, with the area of the shaded region that we do want. Okay, so let's look at our last part of this example. The last part of the example says that we want to determine the area under the normal curve between negative 1.82 and positive 1.67. So again, we're going to draw this curve. We're going to mark a line down the middle, which will be 0. Remember, positive z-scores on the right, negative z-scores on the left. So we're going to mark off negative 1.82. And we're going to mark off on the other side 1.67. And we want to find the area between these two values. And so I'm going to shade this section in between the two z-scores that I marked off. So let's go to our table. We're going to need to use both tables because we have a negative and a positive. So let's go to the negative table first and look up negative 1.82. All right, so if our z-score is negative 1.82, we are going to look at negative 1.8 and the 2 across the top and intersect those two, giving me an area of 0.0344. All right, 0.0344. Okay, so remember that that is the area to the left of negative 1.82. So that is the area right in here. 0.0344. All right, and so I'm going to keep in mind that that is not a shaded part, so I know that eventually it's going to need to be subtracted off because I don't want it included. All right, let's go to the 1.67. We're going to go to our positive table now. And didn't mean to move that. Let's look at 1.67. And so we're going to go down to 1.6 and 0.07 across the top and intersect those two. And that's going to give me 95.25. All right, so 1.67 is going to give me an area of 95.25. Okay, and where is that the area? That is the area to the left of 1.67. So that is going to be the area from here all the way over. So 95.25. And so how do we find the area of the shaded region? Again, we're going to take this total, which is 95.25, and the 95.25 basically includes three sections. It includes from 0 to 1.67, so right here. It includes from negative 1.82 to 0, so this section, and it also includes this section over here that is not shaded. So these three sections make up 95.25. We're going to take off this section that we don't want. And so we're going to subtract 0.0344 from 95.25, and that should give me my answer of 91.81. So the area of the shaded region is going to be 0.9181.